For this next example, the forcing functions of the cosine, which as we already discussed, means that the guess will have to be a cosine and sine. The homogeneous solution is, the homogeneous problem is x prime equals minus 4x. So the homogeneous solution is c1 e to the minus 4t. And so for our guess, since I see a cosine, I'm going to guess both a cosine and a sine. Same frequency. And I'm going to do the same thing as I did in the other two examples. I'm going to plug it into the ODE and let the ODE tell me what those numbers have to be. So the derivative is going to give me minus 2a naught sine of 2t plus 2a1 cosine of 2t. Okay, so this is the derivative of the particular guess. And then we have minus 4 times our guess. So we get this. And then finally we have the forcing function, I ran out of space, plus 15 cosine 2t. Okay, the next step is to group all the cosine and sine stuff together. I'll bring everything over to the right-hand side and do that. So then I get 0. If I group all the cosine terms together, I get minus 4a naught, minus 2a1, plus 15. Those are the cosine terms. And then I gather all the sine terms together. We get 2a naught minus 4a1. These are multiplied times the sine. And so this thing has to be 0. And it has to be 0 for all values of t, which means each of the coefficients has to be 0. And this gives us our linear system of equations. So then we get minus 4a naught minus 2a1 has to equal to minus 15. And we have 2a naught minus 4a1 has to equal to 0. So again, we did this what we did before, right? We took an ODE, and by this guess, we reduced it down to a system of linear equations. And now we go ahead and solve this. I'm going to do the matrix formulation, because I like to take inverses of 2 by 2s. And so in the matrix formulation, I get minus 4, minus 2, 2 minus 4, times the a naught, a1, it's minus 15 and 0. Take the inverse of the matrix, determinant's 20. So we get a naught, a1 is equal to the inverse of that matrix. Determinant is 20, so it's 1 over 20. Switch the diagonals, which does nothing, because they're both the same entry. Negative of the off diagonals times a vector minus 15 and 0. And we get then this is equal to the vector 3. And 3 has, if I've done this correctly. Yep. Okay, and so then our particular solution is given by 3 times cosine 2t plus 3 halves sine of 2t. And the full solution is the homogeneous plus the particular again. Okay, our last guess, our last problem. There's a little trick here that we have to worry about. So here for our last problem, it seems very much like the first problem. The homogeneous solution is x sub h is equal to c1 e to the minus 5t. Okay, that seems fine. The forcing function has an e to the minus 5t. So I'd guess a naught e to the minus 5t. But there's a problem with this. The guess seems fine, but there's a problem that we have to deal with. The problem is that when I look at the homogeneous solution, I have an e to the minus 5t. When I look at my guess, it's e to the minus 5t. It's the same thing. So it's not going to work. You can check it to see if you want, but in the end, if we plug that in there, we'll get 0 equals 7, and that simply doesn't work. So what we have to do is, because the homogeneous solution is the same thing as our guess, we have to modify the guess. And so we'll take a new guess, and the new guess simply, all I do is take the old guess and multiply it by t. If I had time to go in the explanation of why this will work, but in the end, the only way I'll see if it works, if I plug into the ODE and see if I can get an algebraic equation out. So I'm going to plug this in and see what happens. So I take the derivative. Product rule says the derivative is a naught e to the minus 5t minus 5 a naught t e to the minus 5t. So that's the derivative of my guess. I want this equal to minus 5 times a naught t e to the minus 5t. And then I have the forcing function, which is plus 7 e to the minus 5t. And if I look at both sides, I see that some nice things will happen. In particular, both sides have the minus 5 a naught t e to the minus 5t. So that part goes away. And so in the end, we're just left with a naught e to the minus 5t is equal to 7 e to the minus 5t. That's easy to solve, because we can cancel out the exponentials, and we get a naught is equal to 7. So it worked. So we get the particular solution then is going to be 7 t e to the minus 5t, and the full solution is a sum. So it'll be c1 e to the minus 5t plus 7t e to the minus 5t.